Hi, welcome to the first ever Google Hangout from Astronomy Magazine and Discover Magazine. We're very excited to be here with you today. I'm Dave Eicher, the editor of Astronomy Magazine, and I have a number of guests with me, and we're going to talk. We're very glad that all of you are joining us today, and we're going to talk about Comet ISON and comets in general. And I'd like to briefly introduce our panelists who we have here today. We're very honored to have Corey Powell, who's the editor-at-large of Discover, and a fervent amateur astronomer and comet buff. Rich Talcott, who is the senior editor of Astronomy and has been observing comets for many years. Sarah Scholes, one of our associate editors of Astronomy, who is very interested in all sorts of aspects of the science and hobby of astronomy, including comets. So we're going to be fielding some questions and interacting with you and sharing some images of Comet ISON starting fairly soon. But I'd just like to, before we get to questions, put it into context a little bit here for us, because we have a rare event going on in the solar system right now. Comets are around a lot, and they're on the perimeter of our solar system, a very, very long way away from us, in the Oort cloud, a big spherical shell of a couple trillion comets, which are essentially blocks of ice. Most comets are about a mile, a couple of kilometers across. Some of them are larger. They're mostly consist of frozen water, about 80% frozen water ice, and other compounds like methane and other terrible things like that. And then there are dust particles that are locked up in these comets. And it's a rare event when one of these things gets gravitationally kicked in, pulled in to be very close to the sun, as ISON warms up, forms this very magnificent tail, and shows us a rare spectacle in the sky of something moving from day to day to day. That's an amazing thing. This comet will be at its brightest about a week from now, as you may know. So I saw my first comet my first comet that I enjoyed. I saw Comet Kohoutek, but I saw Comet Vest in 1976. Really loved it, and it got me into observing astronomy. I'd like to just briefly mention that we have this special issue of Discover and Astronomy Magazine, the Great Comet of 2013, that will give you full maps and charts and discussion of everything there is to know about ISON and how to see it. It's out on newsstands now. And if you're really into comets, I have a book that has just come out from Cambridge University Press called, cleverly enough, Comets, Visitors from Deep Space, that has a whole lot of information about comets of the past and present. So without further ado, we'd like to talk a little bit about comets, ISON in particular, and comets in general. And I'd like to throw the first question out to Rich Talcott to start us off. Rich, what makes a great comet?
It's a good question, and it's not something that people know for sure. It's one of those things that if you see a great comet, you know that it is one, but there's no standard definition for one. Typically, if a comet gets brighter than magnitude 0, which we expect ISON will next week, that would qualify it as a great comet. But it also helps if it's visible in a reasonably dark sky, which next week, unfortunately, ISON will not. But we hope that it will in December when it pulls out into the morning twilight and should become what we think is going to be a great comet anyway.
And let's all of us talk just for a minute about how ISON is doing now, because when it was discovered 14 months ago, it was going to be the greatest thing in the rest of our lives, and brighter than the full moon. And then there was a period about a couple months ago when there were a lot of stories and blogs and press about how it was a dud, and it had fizzled, and it was going to be the worst comet we've ever known about in history. So where is Comet ISON now? It's actually up to naked eye visibility now, although it's slipping close to the sun. And what's it going to be like a week from now, and then when it's perhaps at its best in early December? Do you all want to sort of kick in a little bit? Because there's some interesting things going on with ISON and its behavior now. There was a major outburst, and there's a possibility of some unusual wings around the inner part of this comet that led some people to think that it may be breaking up.
I do know that as of the latest outburst, the number of molecules that are escaping from the comet has increased about 8 times just since yesterday, and it's currently spewing out 10 with 29 zeros worth of molecules behind it every second, which is enough to fill an Olympic swimming pool in, according to bad astronomer Phil Plait, about 10 minutes as of this morning.
And gentlemen, are you optimistic about the comet a week from now and later on?
Well, I think, it's been interesting. This comet so far has confounded almost every expectation, which is part of the reason that the predictions have bounced back and forth so much. From looking very, very bright early on, which may have been a sort of an anomaly from an early outburst, then kind of underperforming, then, as you said, recently, sprouting wings, the activity kicking in. Even veteran comet hunters, people like John Bortle, who've been watching comets all their life, have kind of shrugged and said, this comet doesn't look like any other comet I've ever seen. But then again, every comet doesn't look like any other comet we've ever seen. One of the hallmarks of comets is that each one really has very much its own distinct personality. That's why people have been hedging so much with predictions. It's also what's so exciting to watch right now.
And there's that old saying from our friend David Levy, the comet discoverer, that comets are like cats. They have tails and they do exactly what they want. And it is very, very hard to predict. But the Minor Planet Center now today is predicting that for a few hours, ISON will be up when it's closest to the sun, up at about magnitude -7. So that's going to be very difficult to see the comet when it's that close to the sun in our sky on Thanksgiving. But that's pretty bright.
The interesting thing is that's actually pretty close to what the consensus estimate was at the Comet ISON observing campaign. On the website, they put a whole range of predictions, and their consensus prediction was that it would be a few times brighter than Venus at its peak, which is right about -7.
Yeah, I think it's fair to say that right now it's about 4th magnitude, which doesn't sound all that bright. As you mentioned, Dave, that's visible to the naked eye if you know where you're looking in the eastern sky before dawn. But if it gets up to -7, that's about a factor of 10,000 brighter than it is right now. And that's brought to us by the fact that it's going to be a lot closer to the sun. Right now it's about 57 million kilometers away from the sun, and it's going to drop to within 1 million kilometers next Thursday. So in 8 days it's going to move 56 million miles closer to the sun, and that's what should zap its brightness way high.
So it's really speeding toward the sun very efficiently now and speeding away from Earth more or less. It's about 129 million kilometers from us. So it's not a comet that's coming very, very close to Earth as Yakataki or Iras-Araki-Alcock did in 1983, but it is a comet whose brightness is because it will be a result of it being very close to the sun.
Well, and I think it will be. I think it's going to be so close that it's going to be going like 600 kilometers per second at the time that it gets the closest to the sun. The sun's gravity will be making it go that fast.
That's a pretty enormous slingshot effect.
It is. Way to go, sun.
And there's been some discussion. There was, in fact, even early on, although a lot of comets, as you can see from looking at the SOHO data and the online observatory images shot by SOHO, that have actually done, a dive straight into the sun and died as a comet because of that. 1.8 million kilometers is close, but it's not incredibly close. But early on, there was talk of this comet breaking up. And we saw last week with these wings of structure coming off a little bit of the comet that maybe that was a sign that it was fragmenting. And even if it did fragment, that didn't necessarily mean that the comet would disintegrate completely. However, now in the last day or two, there's some discussion about this disintegration. Rich, you were talking about that earlier this morning.
Yeah, usually when a comet fragments and eventually disintegrates, it starts to look a little bit asymmetrical. And so far the images from this morning and yesterday morning show it that it's very symmetrical still, which is unusual for a comet that's breaking up. Should add that just because a comet breaks up doesn't mean it's going to disintegrate totally, and a comet that breaks up exposes a lot more ice to the sunlight as it's passing near. So a breakup is not necessarily bad news for comet observers, although if it totally disintegrates, obviously it would disappear.
Right. We've actually had great comets that broke up into pieces and produced an amazing display as a result. I think the concern was that, that the comet might break up and essentially disintegrate entirely at the perihelion, so that after Thanksgiving, when you're looking for the comet in the morning, that in the morning sky, that there wouldn't be much to see. But so far, there's no evidence of that. The other thing that's kind of interesting is that when comets break up during close passage to the sun, they basically do it because of gravity, not because of heat. Any reasonably large comet stays cold on the inside. It's actually boiling off as fast as it's heating up, and so it's really the gravitational forces of the sun, not the heat of the sun, that causes them to break up.
That's right. Now we have a reader question a viewer question from Adrian, and Adrian would like to know, what's the best time to see the comet? Is it in the morning? Is it in the night? How do you go about seeing this comet we've heard so much about?
Right now, the best time to look for it is in the morning sky. In fact, tomorrow morning is the first morning where it rises during twilight instead of in the dark sky. But if you go out tomorrow morning and look toward the eastern sky, it should be fairly obvious if you're looking through binoculars. A good set of objects to kind of guide you to it are the planets Mercury and Saturn, which are also low in the eastern sky, and they will be within about a binocular field or so of the comet during the next several days. So yes, right now morning sky is the best time, and after it passes perihelion in early December, it will also be a morning object for the first week or two before it becomes visible all night long as it climbs high in the north.
But while you're looking in the morning, you just really you need to be careful not to stare directly into the sun in your active pursuit of the comet.
Right. Once the sun comes up, you aren't going to be able to see the comet anyway. Certainly not until closer to perihelion. So once the sun comes up, you can stop observing.
Yeah, I think the real issue, what Sarah was alluding to, is people have talked about, oh, you might be able to see the comet in the middle of the day when it makes closest approach on November 28th. But if it does, it's going to be just over 1 solar diameter away, and think about the glare and how difficult that is to do. I mean, as you said earlier, it'd be a very, very challenging observation, and it's also it's an observation you have to do very carefully. You have to know exactly how to block out the sunlight to give yourself a safe opportunity to see the comet.
But the best way to see it when it's near perihelion is to go to the SOHO Observatory's website, because it's a solar observatory that looks at the sun and actually is able to block out the sun's brightness.
Right, but don't look at the website directly, but the website is very dangerous.
But the spacecraft is able to block out the sun's disk, so you see interesting objects like comets right nearby. And for about 4 days around the time of perihelion next Thursday, it's going to be inside the wide field view of the cameras.
Sarah, you have some photographs of this comet that are recent that you'd like to show us, and they're really quite incredible, because some of them show not only a fairly sharp and well-defined coma, and we know this comet is a relatively small comet. We don't know what its nuclear size is, the size of the ice, but it's 2 kilometers or less, which is a pretty small ordinary comet. But there's some extraordinary now structure in the tail, isn't there?
Yeah. I will share my screen of pictures with you. Just hang on for 1 second. Okay, I'm going to skip ahead to a few of the more recent ones. These are from October. This image is from Hubble, and it was taken November 2nd, just after ISON's first outburst, when it increased by a factor of 2 in brightness. And you can see that it's still kind of smooth, and there's whole lot of structure visible yet, but just after this after this image is when another burst occurred that made Comet ISON get brighter by a factor of 10, and you can kind of see some color differences in this one. The tail is a little bit more red than the coma, which is the bright part at the leading edge of the comet, and that's because the blue sunlight reflects better through the coma around the comet, and the red sunlight reflects better off the dust that's in the tail. This one might look a little bit unfamiliar. This is not how we typically think of comets, but this is how ISON looks in the X-ray, and this is from the Chandra X-ray Space Telescope. Getting a little bit.
Can you talk for a second about why you see a comet in X-ray?
Yeah, sure. The X-ray emission comes from when the neutral atoms that don't have any electrical charge that are in the comet's coma, or that little envelope of material that surrounds the actual solid part of it, and the charged atoms from the sun. The sun is sending out these charged particles all the time out into space, and when they interact with the neutral atoms in the coma, they start to emit X-rays. Do you guys have anything to add to that? Okay.
Nope, that sounds good.
All right. No one knew about comet X-rays for sure until 1996, by the way, with Comet Hyakutake. Let's see. This one is from November 8th. It is 1 hour of combined exposure time, and this was taken by Chris Schur in Payson, Arizona. And you can see that it's still looking pretty smooth. We don't have the structure quite yet. But then 2 days later, on November 10th, an astroimager named Damien Peach, who's in England, took this image of ISON through a 4.3-inch telescope, and you can kind of see at least 2 separate streamers coming out of the comet at this point.
Yeah, the full version of that image is really spectacular. That may be the most beautiful one I've seen, that Damien Peach one.
Yeah, this is actually an earlier one than the really, really stunning one. We have that one coming up too.
Okay, good.
Don't worry. This one is from November 14th, and it was taken by Carl Wenning, Bob Finnegan, and Tim Stone. And again, you can kind of see as you get closer to the coma, there's a little bit more structure coming out of the tail. And I think this is maybe the one you were talking about, Corey.
Ah, there we go, yes.
There we go. Yeah, this is Damien Peach about a week ago on November 15th using an 8-inch telescope. And it's got a lot of, there's, I don't know how many, you can count at least 9 different elements of the tails coming out there. I don't know, do you guys have anything you want to say about this, the structure that you can see in this image?
Well, I think if you look at the pictures we've seen of other cometary nuclei, you know, all the space probe images show there are really well-defined areas where the jets come out, and so what you're probably seeing here is this is the long-range version of, you know, different ejections of material from the comet. It's very cool that you can see that. And
also material of different density and mass that's resistant to the solar wind in different ways as well, that forms these kind of linear structures. And
right,
also
shows a lot of heterogeneity in the comet, that this comet is not just one evenly mixed batch of material.
That's right, and it's also related to how the nucleus of the comet is rotating, the origin of this stuff, which we don't know. It's a complete unknown as yet.
And next, speaking of complicated, I do have an image of those wings that you were talking about, Dave. And this is it. This is from the Wendelstein Observatory, taken on November 16th, and there are these 2. It kind of just looks like an arch around the front of the comet, and there's speculation that this is because chunks of it are breaking off and affecting the shape of the tails behind it, as you guys were saying. And we have one from today, actually. I believe. Maybe we don't. I guess we don't have the one from today, but this is one from a day later after the wings appeared. So here we have the wings in a different view, and can't quite see them in this image, but it is from a day later, so theoretically they're probably still there. And those are the images that we have, and a bit later we'll show some of the images that you, the Google Plus viewers, have sent to us.
Excellent. And now we have a question from Google follower David Latimer. Do comets regain the mass they use as they approach the sun when they recede?
It's a one-way weight loss program. I mean, so part of what's interesting about comets and about Comet ISON in particular is, I mean, you can think of this as the very, very last stages of the formation of the solar system. This is a chunk of material that came together about 4.5 billion years ago, got kicked out of the solar system probably by Jupiter's gravity way out to the outskirts, and it's coming back now for the first time. So it's material that never got incorporated into the other planets, and in a way, that's happening now. Some of that material is going to end up in the sun. Some of it, you know, we're talking tiny quantities. A little bit will end up in the sun. A little bit will end up at the planets. Some of it will get blown out of the solar system. This is just the tiny, tiny tail end of a process that was happening very intensely when the planets were forming.
And there
That's
are...
right. And I'm sorry, Sarah.
Sorry. Oh, I was just going to say there are objects that have lost all of their material that can fly off. All of their ices and things like that have sublimated out, and they're no longer active comets. They can get close to the sun, but there's nothing left to lose. So they're just sad.
Well, you're right, and it also brings up the changing relationship and understanding of asteroids and comets. Asteroids being rocky small bodies and comets being icy small bodies with volatiles. And it's clear now that some objects that were thought to be asteroids are ex-comets, are defunct comets. So this is one way that comets die, is that they lose all of their volatiles. Or they can plunge into the sun, or they can, like ISON, be in a hyperbolic orbit and be cast out into space forever and ever, or at least back into the Oort cloud in an orbit that will not bring it back. So there's only one thing you can do, as Corey said, and that's lose mass as a comet, and you'll never regain it. Okay. I tell you, why don't we go to a question for Rich. How did Comet ISON get its name?
Well, it's a kind of an interesting question, actually. It was discovered in Russia on September 21st of last year, so a little bit more than a year ago. And the two astronomers who discovered it sent their observations to the International Astronomical Union, which is the clearinghouse for all discoveries of comets and asteroids. But they didn't notice that it looked like a comet at the time. And between that day, or that night, and the next night, several other people looked at it and noticed that it was a comet before the discoverers did. And for that reason, their names do not get onto the comet, but it's named instead ISON, which is an acronym for the International Scientific Optical Network, which is who runs the telescope that they were using at the time. So they failed to become famous in history simply because they did not notice that it was a comet when they first made the discovery.
So the moral is move quickly. But the other thing I think is interesting about that is, you know, if you ever listen to any of the conspiracy theorists who say, you know, that the comet could be doing this thing or that thing, and there's a NASA cover-up, there's so many people looking at the sky in so many different ways. Not only could you not cover anything up, but they couldn't even keep priority on this comet for one day.
That's great. Let's move on to something that has always fascinated me and others who like to think about comets. Comets have always had a special grip on human imagination, and in terms of observations, that goes back to the Caesar's comet, Julius Caesar, that was visible in the Roman sky after Caesar's death and was thought to be symbolic of Caesar's soul going to heaven. The great comet of AD 79 was linked to the disaster at Pompeii and Herculaneum with the eruption of Vesuvius. Halley's comet in 1066, it wasn't known to be Halley yet, but the great comet of 1066 loomed over the battlefield at Hastings during the Norman conquest and the rise of William the Conqueror. The comet of 1665 in London was linked to the Black Death, and so on and so on and so on. And this leads right on up into the apparition of Halley in 1910, when Camille Flammarion, a French astronomer, famously had the whole world freaking out because of his alarm over the detection of cyanogen gas in the tail of Halley, thinking it may snuff out life on Earth. Why do comets, have they for a couple thousand years fascinated people in this crazy cultural way like no other objects in the sky?
I'll take a crack at that. I mean, I think, look, I mean, there are two things about comets that are very unusual. One is that they're unpredictable. That you can make very good tables of when the planets are going to appear. The stars obviously are entirely predictable. Comets are just, they show up when they show up. So they have this kind of rogue element to them, and they don't look like anything else in the sky. Everything else is pretty much is a dot or a disk, and it has some very regular aspect to it. Every comet looks different, and it looks like nothing else in the sky. And so I think those two things make them seem very, very portentous. That it's something unusual and it's something unpredictable in the sky. And I think that's still why we get excited about it. The idea that the sky looks really very different from night to night, and that we don't know what this comet's going to look like. We don't know exactly how bright it's going to be. We don't know what the tail is going to look like. With each new picture, you don't know what you're going to see. There aren't very many things in astronomy that are like that. It's very exciting.
Right. Yeah. I've never spoken to anyone from Julius Caesar's time, unfortunately. But I'm going to venture to think about what they were thinking. And, I mean, when you go outside at night, especially in a time before telescopes existed, things pretty much look the same. I mean, the stars and everything else rises and sets, and the planets move a little bit relative to that. But you can kind of count on the fact that when you go outside, you're going to see points of light in the sky. And then, as Corey said, you go out there, and not only is there this thing that has just appeared out of nowhere, but it looks really different from everything else. And I imagine that if that happened now with something that was not a comet, we would all freak out and blame it for lots of bad things that happened until we put our science hats on and tried to figure out what it was.
Right. I mean, just think, I mean, through a lot of history, astrology and astronomy were not really well distinguished from each other. The idea that planets, influence events on, events in human society and affect you personally, that was a well accepted idea. So if you have all these precise tables of predictions that tell you where the moon is going to be, and when eclipses are going to happen, and where the planets are going to be, and you think that those things are very important to the way that the world works, all of a sudden a rogue element, that's a scary thing.
I'll just add one more thing too. The only other kind of object that really shows up like that are exploding stars like novae or supernovae. But the thing about them, which obviously were also of interest back in the day to early observers, is that they stay in the same spot in the sky from night to night and week to week and month to month, as long as they're visible in the sky. They don't move relative to the other stars, whereas comets do. So there was certainly something different about comets that the people back then had no clue what they were. So that's people are always interested in things they don't understand, and comets certainly remained in that realm well into the second millennium.
And let me just add one additional detail, which is, so, in 1066, there was an appearance of Halley's Comet that shows up in the Bayeux Tapestry. It's one of the most famous early depictions of a comet. Well, that's just 12 years after the Crab supernova went off. So here's this comet that was very well recorded and remarked on across Europe. Here's the Crab supernova, which is not recorded anywhere. Somehow, people process these two kinds of events in a very different way.
Well, I think, like as Rich was saying, they do move relative to other things because they're closer by, and because of that, for a long time, people thought they were actually inside of Earth's atmosphere. That was something that Aristotle thought that held on for a really long time, actually until like the 16th century. People thought that they were inside.
Until the Great Comet of 1577. So from the earliest thoughts until the time of Tycho, you're right, Sarah, they were thought to be atmospheric exhalations, was the term.
Right, and I'm scared of those. I'm scared of those.
I'll throw out one more thing about the supernova of 1054 that Corey mentioned too. It was recorded in Asia and apparently in North America too by early residents there. And one interesting aspect may be that 1054 also happened to be right around the time that the Catholic Church was breaking up in Europe. And religious people tend to look at portents in the sky as something significant, and perhaps the 1054 supernova did not get recognized or recorded in Europe because they thought that that was a sign from up above that something was wrong about the split in the church.
Why is it that they were taken as either signs of good or bad, but 9 times out of 10 it was something really bad? There's something about the human character that we can derive from that, I think. Huh? But now we've got a reader question. Why doesn't the comet ISON have the classic 2 ion and dust tails?
I can go for that one.
Okay.
It seems at the moment, anyway, that it's releasing a lot more gas than dust. And what happens in that case is that as sunlight ionizes the molecules that are given off by the comet, it creates the ion tail. So without as much dust production right now, it is not quite as bright, or the dust tail isn't quite as bright. But the angle at which we view the comet is also something that plays into that. And probably in December, we should be able to see both a dust and an ion tail as 2 separate entities.
Very good. And let's just go back to that idea, because it really is fascinating, and I think you can talk a little bit more about this, of the incredibly slow progress in terms of understanding comets physically. In very ancient times of, believe Aristotle and onward, believing that they were atmosphere, that they were either areas of different humidity or of gas that were released from Earth's surface and were in our atmosphere. And then it was Tycho in 1577 who was obsessed with that great comet, who made the first parallax measurement and showed that the comet was so-called superlunar, that it was beyond the moon, and still didn't get the distance exactly right. But then it was about a century later when this guy Isaac Newton came along, and he had a friend who was very interested in comets and conspired with him to observe a number of bright comets in the late 1600s. And then eventually that was tied up in gravitational theory that Newton was working on and arguing about with Robert Hooke, and eventually getting his publisher, Edmund Halley, to produce the Principia, or the greatest book of science perhaps ever. So it took really nearly 2,000 years, 1,700 years plus, to understand that comets were distant things and that they were also moving on basically elliptical paths. For a long, long time, up until those times, even if a comet was seen on one side of the sun and then another, it wasn't clear, amazingly enough, that that was the same object in movement. People thought those were 2 different comets. And it's really incredible. It tells us something about the way science works, this story of the long, slow figuring out of how bodies move in the universe.
I think it tells us that people in the past were not quite as smart as we are.
Well, I'd hate to put myself back into the Middle Ages and try to figure it out. It's the standard. It's a little unfair for us to look back and be too hard on them. But it's an amazing story of how science sometimes is a really gradual process of things not falling together for a very, very long time until certain key people come onto the scene and see things differently.
Right, well, and especially in astronomy where you have to wait for things to happen. You can't will a supernova to happen or a comet to arrive for you to see. You have to wait for them, and then it depends who's working then, what the thought is then, and
Now wait a minute. You're saying that I should stop lying in bed at night trying to will this to happen?
I don't want to tell you what to do.
No.
Okay.
But actually, I mean, that brings up a great point, which is, I mean, part of the reason that the scientists are so excited about this comet, beyond the fact that it's, that it's bright and has the potential to be a really beautiful naked eye object, from a scientific point of view, this type of comet, called a sun-grazing comet, that passes very, very close to the sun. Typically, I mean, the vast majority of the sun grazers that people have seen They're very small objects, only maybe some tens of meters across, and they're discovered very shortly before they pass by the sun or disintegrate completely. This comet was seen, obviously, way back in September of 2012. It's a lot of time to prepare, and comets often don't give you a whole lot of advance warning. So, it's both an interesting type of comet because it passes close to the sun. It's really, a lot of stuff is going to boil off, and we got a very, very early look at it because it was so bright while it was so far from the sun. And so, as you say, you're always hoping you can just kind of will this thing to happen, that you want to wait, you want to will the exact kind of comet you want to study. This is actually the exact kind of comet that astronomers want to study and that they almost never get to look at. So that's, from a scientific point of view, that's why the scientists are very, very worked up about this, even if it turns out to be something of a disappointment as a naked eye object. From a scientific point of view, this thing is, this is a payday.
And let's talk a little bit, while we're talking about that, about why should we care scientifically about comets. And there's a lot of work, it's almost been a cottage industry over the last generation about tying comets to water on early Earth, because after all, there are a couple of trillion comets in the Oort cloud, there are a lot more of them in the Kuiper belt and in other inner places in the solar system, Jupiter family comets and others. And comets are 80% water ice. So the assumption, the almost leap of faith there from the 1980s and 90s onward is that comets bombarding Earth, because we know there was a huge bombardment of material coming in to the inner solar system bodies, 4+ billion, contributed an enormous amount of water to Earth. But then the story gets tricky, and you see that the ratios of deuterium to hydrogen are different in most all comets than they are in Earth-ocean water. And so it turns out, we can discuss this, but it turns out that comets probably contribute about 10 to 15% of water on Earth. And there are other things like ice-rich asteroids and the water particles actually adhering to dust grains that made up Earth's core and mantle contributes a lot of water to our planet, but they also contain organic molecules, including glycine and amino acid. What do comets tell us about a connection to organic molecules and life on Earth, possibly?
Well, they tell us what material was available in the very early solar system, because comets formed a very long time ago, just as the solar system and the planets were forming. So they're basically a museum of what the solar system used to be like. So if we can find these organic molecules and find out they existed early, that tells us something about what could have become us eventually.
Yeah, and one of the things that the astronomers are really going to be looking for with Comet ISON is if you can measure the exact mixture of compounds that are in it, you can make a pretty good estimate of where in the solar system it originally formed. And that would be very interesting for testing these different theories. One of the most interesting theories about what was going on in the solar system is a thing called the Grand Track theory, which gets to what you were saying before, that the solar system wasn't this simple place where the planets sort of formed in place and then comets rained down and made the ocean. It looks like the planets were actually migrating around, that Jupiter was moving in and moving out, and as that was happening, everything was getting completely stirred up. And so what you see when you look at comets is that comets that look very cold actually have grains of material in them that look like they were formed in places that were very hot. And the Earth has, as you said, a mixture of comets, but also icy asteroids and all these different places where the water came from and maybe where the organic material came from that got life started here. So each time you observe a comet like ISON, you fill in another piece of that picture, and we're starting to understand that there's this incredibly complex process that it took to create our planet, to create the water, to bring organics here, to make all the things that it takes to make our planet a habitable place.
You're absolutely right, Corey. And planetary scientists found a really incredible mineral in the material that was returned from Wilt 2 from the Stardust mission, osbornite, which is a very rare mineral. It's titanium nitride, and it's obvious, it's clear that forms, just as you said, at very high temperatures. This is in a comet that spent nearly its entire existence at least out in the area of the Kuiper Belt or beyond. So what the heck is this high temperature material doing in there? Well, it's clear that there was not only planetary migration, as you said, but a lot of mixing of materials in the early solar system, and perhaps a bipolar blast of winds carrying high temperature minerals out into very distant regions and depositing them into these comets in the very early solar system. So it was a very violent, scary place in the early days of the solar system on a much bigger scale than anyone really knew before that finding.
Just imagine how scared people would have been of comets then, if people had been around.
Let's go to a reader question. Anna asks us, what determines the traveling path, the orbit of a comet?
I can handle that one. It's about 99.9% gravity. So Isaac Newton, as Dave was talking about before, it was able to predict the paths of comets once they knew the laws of gravity and the laws of motion very precisely. The extra 0.1% happens because sometimes, and Comet ISON is one case, they have jets of material coming off of them. And those jets actually act like little rockets that can actually change the motion of the comet slightly. So that was something that was first found out about Comet Encke, which was the second periodic comet known, that it showed up a couple of weeks different from what the predictions had been, and that was simply because it was jetting out this gas that was slowing the orbit down.
Okay. Now, Sarah, you have some viewer-submitted images of Comet ISON for us, do you not?
I sure do.
Are you
Yes.
willing to share some of those with us?
I would think about it. Yeah. Yeah, I would love to. We have 9 photographs of comets that people have submitted that are mostly from the past week or so after ISON had its first outbursts and got very bright. This first one, sorry, I was in the wrong spot. The first one is by a user named Tony Angel, and this shows the comet over a period of time, and the last one I believe was taken on the 15th. And these were taken from an observatory in Spain, the SON at OSC Observatory. And the third one was taken Wednesday after the outburst that happened. This one was taken by Ernie Mastriani, who actually is photo editor at Discover magazine. So this was taken outside of Milwaukee, and he took this image to show what ISON would look like through binoculars, perhaps. And at this point, when he took the picture, he said it outshone the 5.5 magnitude star that's at the bottom left. And this is from last week. I'm not sure which day. Our next one is from Bob's Barn Lot Observatory by Bob Wheatley, and it was taken November 14th. And this is a 10-minute exposure, and you can see the coma looking really bright, and you can see a little bit of structure in the tail too, like we were talking about earlier. This one is from James Foster, and it was taken November 15th, and you can clearly see the different colors, which I briefly mentioned earlier, where the tail looks more red than the coma does. And at this point, when it was taken, the comet was at magnitude 5.4, and it was 84 million miles away. This is by Tim Forrest. And it was taken on the 15th, and it was magnitude 5.04, and yes, it was the same distance away. This is another one from the 15th. The 15th was a very popular day for comet imaging. This is by Tony Carlos from, this is the view from Woodland, California, just before dawn, and the color of the coma looks, I like it. By the way, you guys, if you have anything that you would like to add about these, feel free to jump in. And this one is from a user named Khalil Azar from Lebanon, and this was taken on the 16th. And this is an 8-second long exposure, and you can't leave your eyes open that long. So this isn't quite the view that you will see. But it does show it against a horizon and against a larger star field, so you can kind of see how it would look if you were not looking through a telescope or binoculars, but it won't be that bright necessarily right now. And the second is also from Khalil, and he took advantage of I guess this is another one from the 16th, and this is a time when there was not very much moonlight, so he was taking advantage of that, and the moon has been drowning out a little bit lately. Our second to last image that we have to share is by Glenn Worden, who's in Los Alamos, New Mexico, and this was taken on the 18th. It is 3 images that are added together to produce this one with 90 seconds of total exposure time. And just to give Glenn a little extra credit, he noted that the moon was up while this was taken, there were low clouds on the horizon, and there was frost on his lens. But it looks pretty good anyway, I think. And this is also by Glenn. It is a stack of 4 20-second exposures. So if you have a camera, tripod, telescope, you might want to think about getting out there and taking some images of the comet. It's looking pretty great.
Those are fantastic, and of course it's much easier now than it ever has been to do astrophotography and to capture images. Of course, you need a DSLR. You can't really do it with a cell phone camera yet, but it's a lot easier than it was, say, a decade ago. Corey, why did astronomers call ISON the comet of the century?
Well, there's sort of 2 answers. The 2 Russian-based astronomers, I guess they were really Russian-based observers who discovered the comet in their initial media report, called it, in slightly broken English, a maybe comet of the century. They ran their initial calculations of how bright the comet would be, and they figured out that at closest approach it could be potentially brighter than the full moon. And now, as we mentioned earlier, it's almost certainly not going to get that bright, and even if it did, it would be that bright, less than a degree away from the sun in the sky. So, but they got excited and they called it, maybe a comet of the century. And I think that caught on. It's got a sort of an OJ kind of vibe to it. It's a catchy thing. It's another way of saying great comet, that this could be a really spectacular object to see. The interesting thing is that from an astronomical point of view, it's actually even better than a comet of the century. Again, it may be that it isn't a comet of the century as a naked eye object. Certainly, a Hale-Bopp is going to be hard to beat. Comet Vesta is going to be hard to beat, as you mentioned. But as a scientific object, I was saying earlier, it's a comet it's passing very close to the sun. It's a fresh comet from the Oort cloud, so it's a comet that has not been close to the sun anytime in the past 4.5 billion years, and it's much bigger than the usual sun-grazing comet that we see. So, I asked some of the experts in comet dynamics, when was the last time that we've seen a comet like that, a large Oort cloud sun grazer, a fresh comet passing very close to the sun, so that you get to see exactly what it's made out of? And the answer was never in recorded history. Not in the past 200 years that there have been well-recorded orbits for comets. So, at least in the past 200 years, there hasn't been anything like it. So in that sense, it's better than a comet of the century. It just might not be a comet of the century in the sense that you walk outside and you see this incredible thing in the sky, but it still has potential to be that too.
And the instrumentation is so much better now. The spectroscopy of this fresh ice from a comet that's really is a window back to the beginning of the solar system. Not one of these, dime a dozen, evolved comets that's warmed up and refrozen and has a cruddy mantle of a whole bunch of. This is a fresh ice, so we're really getting a chemical spectroscopic look at really what this comet was like when it was newborn in the distant part of the solar system.
Right, and one of the reasons it was probably so bright early on is that you had these very volatile gases. You had carbon dioxide and carbon monoxide, and maybe organic molecules that have been irradiated over billions of years. You had these very, very fragile, very volatile molecules that blew off very far out with just the faintest hit of heat from the sun, because the comet had never been heated like that before. So these kinds of comets can be misleading that way. They do a lot very early on because it's the very first time they've ever been disturbed. And it's what makes it hard to predict. It's what makes it kind of confusing, but it's also what makes it exciting.
That makes it kind of fun. Yeah.
It does. Who wants to know what's coming?
I'm sorry. Did you have more, Corey?
Oh no, I was just saying, you know, it's great. It's great being surprised.
Yeah. Yes, indeed. Yep. Rich, for some viewers who may have joined us after the early first few minutes, let's tell them. Can you tell them a little bit about how will it be? How should you go about seeing the comet post perihelion, when the moon is going to be out of the sky now, when the comet's going to be back in the morning sky? It'll have passed the sun and survived. We know that. We're crossing our fingers. We think it will survive, though. That's the best time really to see it, is after Thanksgiving, back in the morning sky. Could you talk a little bit about how to look for it then, and what viewers should expect, either with the naked eye or with a pair of binoculars?
Sure. And you're right. One of the problems with viewing it over the last week or so is that the moon has been very bright and in the morning sky as well. It was full this past weekend. But after perihelion in early December, the moon is going to be gone from the morning sky. And so it's going to give a lot of readers and viewers their first opportunity to see it when it's in a pristine, fairly dark sky. Now, it's going to start out, as you might guess, at just after perihelion. It's still going to be close to the sun, but it moves pretty fast, and so it's going to move into the morning sky, be visible in the east before dawn. First couple of days in December, it will still be in twilight, as it is for the next few days. But by the end of the first week, it's going to be high enough to see in a dark sky before dawn. And it should be right around at its peak then, in terms of how bright it appears in contrast to the dark sky. It won't be as bright as it was at perihelion, but obviously then it's in a blue sky during daytime and extremely difficult to see. But after it pulls into the dark sky before dawn at the end of the first week of December, it should be bright. If it doesn't break up, it should be about as bright as a first magnitude star, which are among the brightest stars in the sky. If it does break up as it passes through perihelion, it could be even brighter, because as we've talked about before, this thing is made largely out of water ice, and the surface has been battered by the sun for a while now, so its production will slow down after it passes perihelion. But if it breaks up, it's going to expose a lot of fresh ice that hasn't felt the sun before, and that could cause it to spike in brightness by a significant amount. So I would say week one, the end of week one through the middle of December should be the best time to see it before dawn.
Great, and let's go back to Sarah with a question. Why did scientists only find Comet ISON about a year before perihelion? This thing snuck up on us, huh?
It did, and it's a very sneaky comet, but most comets really are, because think about it, as we've said, they're not really very big. They're just a few miles across, and they're made of this material that the actual object itself really only reflects 3 or 4% of the sunlight that falls on it. And so when it's just hanging out in space, way far away in the Oort cloud, or even as it comes closer, even near Jupiter or something, it's just this 2 mile across object that's not reflecting any light. And I would like to see you detect it if you think the scientists should have found it earlier. And it's really just as it gets even closer to the sun, and the sun starts to heat it up, and the ices start to turn directly into gas, and there's something to see, because the coma, the material that's surrounding the actual object, the physical object of the comet, is much larger than the chunk of ice and dust itself. So it's only when it gets a coma and reflects light that we can see it, and so that's what happened with ISON.
And the real anomaly in that sense was Hale-Bopp, that in 1996, 5 and 6 was extremely bright. It was physically the largest comet ever known, cometary nucleus. We think ISON is something in the range of 2 kilometers or smaller. Halley's Comet is about 14 or so kilometers across the nucleus, the block of ice. Hale-Bopp is 60 kilometers across, and so it was a bright object when it was really, really far out, and that's why it was visible to the naked eye for such a long time. But that's a real anomaly, and this comet is, as Corey talked about, scientifically very, very interesting, even though it's much smaller. Now, we're talking about comets flying around Earth and the Sun here and so on. And there are about 10,000 near-Earth objects that astronomers know about now, some 92 of which are comets, and most of them are asteroids. Should we be concerned about, we know about the KPG impact 66 million years ago, not a good week for the dinosaurs and most other life on the planet. We saw a meteoroid come in and explode and cause a lot of injuries because of broken glass in Russia early this year. Should we be concerned about all this small stuff, the small little guys, icy or rocky, flying around the solar system? And what do we do about it if a comet or an asteroid is going to intersect Earth and we do find it a year or two before the presumed hit?
Well, I've got a couple easy answers for that. I mean, should you be scared of this particular comet? Absolutely not. I mean, you know, Rich mentioned earlier that there's a little bit of uncertainty in the orbit just from the jets of material coming out of the comet, but that's a very, very small adjustment. We know almost exactly where the comet's going to be. It's not going to come anywhere close to the Earth. So this comet, you can scratch that off your worry list. More generally, yeah, there's a lot of stuff, especially a lot of small stuff, floating around in the solar system near Earth's orbit, and you know we're plowing into that all the time. You know, the tiny meteoroids constantly, and as you get bigger and bigger, it happens less and less often, but with more and more danger associated with it. The easy thing to do is just first survey everything, and there's some pretty basic ways of doing that. There's a telescope called Pan-STARRS that's very good at that. There's a new project starting at the University of Hawaii, which is sort of the opposite. It doesn't do a deep survey. It looks very close to Earth, and it's like an asteroid early warning system. And the amazing thing is, it wouldn't take much money to build, let's say, 10 of these asteroid early warning systems around the Earth, and you'd be able to catch probably 80 or 90% of the incoming things. And so you actually would have been able to give, let's say, a day or two of advance warning for that Chelyabinsk meteor that hit over Siberia in February. Well, a day or two warning, everybody would have known to tape up their windows, stay indoors. It would have made a huge difference. And the amount of money to build all of those observatories collectively, the entire network, would cost maybe $10 or $15 million. It's really not, in the scheme of things, it's not much money. It's just nobody's gotten around to doing it.
Yeah. That'll give us something to do in the future, but at least the situation with sky surveys is better than it was a generation ago. You used to be able to say with a straight face that the number of people working on near-Earth objects was smaller, full-time, was smaller than the number of people in a day shift at a McDonald's restaurant. So we're making slow progress, at least. Seriously, yeah.
Yeah, I don't think people need to walk around living their lives paralyzed by fear. So maybe more than concern, we can all just be glad that we can finally be aware of these dark things that are flying around us.
Right, and we know that another large object, it takes about a 10-kilometer object to be a civilization killer, potentially, and that's really big. But another large object, even not nearly that big, it may be 100 million years before we get a really big impact, so don't lie awake at night or sell your stocks yet.
Right. The nice thing that nature's done for us is the bigger the asteroid is, or the bigger a comet it is, the easier it is to see it. So, if there were a dinosaur killer type asteroid out there headed toward Earth, we would know. In fact, we would know probably many centuries ahead of time. So, the fact that we haven't seen it means pretty certainly it's not there.
So we won't need to call Bruce Willis quite yet.
Not yet.
Might be
Okay.
fun though.
Well, and with that, I have to thank all of you, all of our viewers, and with the great questions and the folks who submitted spectacular astro images of comets, of the comet, to us. Corey Powell, the editor-at-large of Discover, thank you so much. Wonderful to see you as always, and be with you. Rich Talcott, our senior editor at Astronomy. Sarah Scholes, thank you guys very much for participating. It's been a joy to be with you, and we hope everyone enjoyed this talk about comets, and we look forward to bringing you another Google Hangout about something or other soon. So thanks very much, guys. I really enjoyed it, and we have to run, but we'll talk to you all soon.
I would say if people have more questions, send them in by email or tweet them to us, and I'm always happy to take them.
Excellent. Thanks, Corey. You can find information on where to look for the comet on astronomy.com, and I presume also on discovermagazine.com. And lots of information, of course, about the magazines and about the brand. There are a whole lot of stuff going on in astronomy and in the bigger world of science as well. And look for that special issue, The Great Comet of 2013, on your newsstand as well. Thanks for being with us, and we look forward to seeing you again soon. Bye-bye.